All right, so we're getting into the fun portion of chemistry, which is looking at the structures themselves and being able to read these line structures and drawing them out. So, the very first thing you want to think about, what you want to do, is that you see these bond line structures, they're drawn and they look kind of like zigzags. Well, each corner is going to represent a carbon atom. So let's see some examples here. What do I mean? Okay, so if I were to say, hey, where are the carbons? Each endpoint represents a carbon. So this is an endpoint, this is another one, corner, 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 corner. Each little corner is going to be a carbon. So that's a carbon, 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 carbon. Let me erase them all. So if we were to count the carbons, 1, 2, 3, 4, 5, 6. Carbon 6. Now that we have our carbons, let's do it again. How many hydrogens are there? Well, each carbon is followed with hydrogens that are not drawn, but they're implied. Remember, the line structure is to show you where all the carbons are located. Then later you'll see nitrogens, you'll see double bonds, etc. But for the sake of this, we're just going to look at the structure of the line and then figure out how to do it from there. So each endpoint is a carbon, and when there's nothing else in it, it's to imply that there's a hydrogen. So in this case, we know that a carbon, if this is a carbon, so let me redraw that. If we were to do this, right? It's the same as doing this. How many do we have? 1, 2, 3, 4, 5, 6. It is exactly the same. You see how in each endpoint there's a carbon? 5, 6. We said that carbon likes to have its 4 bonds, so it doesn't violate that octet rule. In this case, if we were to put those hydrogens in them, this carbon, how many more bonds does it need to be content? It needs 3 more, because look, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And this is going to be our hydrogens. How many lines does this carbon need? It only has 1, 2, 3, 4. Octet, it needs 2 more. 1, 2. Okay? And those are hydrogens. How many more electrons does this carbon need? 1, 2, 3, 4. 2 more. How many does this one? 2 more. This carbon, the same. And this one? 3. Why? Because there's 1 line already, so it just needs 3 more. Now it doesn't violate the octet rule. Perfect. So now we have drawn all of our implied hydrogens in this line structure. So what did we do? We went from this being the same as this structure up here, which is how many? 1, 2, 3, 4, 5, 6 carbons. And how many hydrogens? 3 and 3 is 6. 8, 10, 12, 14. So this structure, this line structure to the left, is equal to the molecular formula of C6H14. It's another way to draw it. So now you're taking this C6H14 and you're making it into a line structure. So now we're going to add a little bit more to it. Now that you know how to read a line structure, let's add a little bit more to it. So what happens when you have a structure that looks like this? Okay, let me do our lone pairs. And then we want to draw our implied hydrogens. How would we go about to do that? So it's the same thing. If you were to see each endpoint as a carbon, It's the same. How many carbons do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one's gonna have 3. 3. Let me make it into a different color. 3, 2, 2, 3. However, this carbon has a double bond with an oxygen. So it already has 2 bonds. So that means that how many do I have left? This carbon already has its octet. Look, 1, 2, 3, 4, 5, 6, 7, 8. So no more hydrogens on that one. So if you were to draw, so this is the same as drawing this, and they were to tell you, I want you to draw the implied hydrogens, but I only want you to tell me the implied hydrogens on this carbon, there's nothing for you to draw. However, if they were to ask you for the other ones, and it's the same as what we just went through, and we are just drawing what I just went through in the red color. There you go. And that one has none. And then that would be the correct way to do it. Perfect. So with that in mind, that is how you read the line structures. Now, that is a double bond. But what happens when you have a triple bond? So when you have a triple bond that looks like this, okay? Maybe a little jarring in the beginning, but later you will get used to it. Just remember your solid rules from the beginning. Carbon, 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 and the carbon, 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 carbon. All right, those are the carbons. What you want to look at is the carbon here at the ends. They're going to need 3 more bonds. Okay, so if they say, hey, draw out your implied hydrogens, no problem. We know that these have 3. We know that this carbon already has 2, so we just need 2 more. The carbon down here already has 2 bonds. We need 2 more. And this is so it doesn't violate the octet. This carbon that you see right next to it already has a full octet. Each bond has 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This carbon, you cannot put 1 hydrogen because it'll violate the octet rule. So in this case, you don't need any more hydrogens. And that would be the same for this carbon here. No more, no hydrogens. You don't need them. All right, so this one, you need 2. This carbon, 2. Last carbon, 3. And that has to do with the octet rule. That's all you want to think about. That's if you see a triple bond. Now you dealt with a triple bond. Now you dealt with a single bond, which is up here. A double bond, which is here. So now that's pretty much all set. But I want you to look at another way that you will encounter these line structures. So what if you have this type of line structure and they're telling you, go ahead and give me the implied hydrogens. Okay, so first let's locate our carbons. Carbon, 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 and carbon. Let's go ahead and put our hydrogens on the ones that we know. We know that this carbon only has 1 bond, so it needs 3 more bonds. We know the ends, always need the 3. This carbon, it's an end, it's going to need 3 hydrogens. What other carbons have we dealt with? Now we have a carbon. This individual carbon down here, let me make it bigger, has this carbon, has this bond attached to it. So how many electrons are in the bond? 1, 2, 3, 4, 5, 6. we need one more bond with one more carbon. So since it's pointing down, you want to keep it clean. You just do pointing down, one hydrogen. What about this carbon? Same deal. This carbon here has already this bond. Each bond 2 electrons. 1, 2, 3, 4, 5, 6. I need one more bond to make my octet and one more hydrogen. Carbon is pointing up, so I'm going to do my implied hydrogen pointing up. And there you have it, all the implied hydrogens. And that is how you draw implied hydrogens. That is how you count carbons. That's how you locate the carbons regardless of the number of bonds. That's pretty much with that. And on the next video, I'll go ahead and cover how to locate them in different types of structures.